In this short module, we will just prove one proposition, that is the uniqueness of limits. Proposition. Let xn be a sequence and xn converges to A. Then xn cannot simultaneously converge to a point B that is different from A. In other words, the limit of a sequence, if it exists, is unique. Proof. Well, let n from 0, 1 to natural numbers be the function that comes from the definition of xn converging to A. Okay. So instead, let me just not take it from 0, 1. Let me just take it from r plus to n. Recall that it doesn't really matter if I had a function from 0, 1 to n that satisfies the definition of convergence. You get a function from r plus to n as well. You will understand in a moment why I had decided to choose the function from r plus to n. Now, without loss of generality, we can assume that B is greater than A. Okay. You please go through the entire proof and check really that this assumption of B being greater than A is really actually without loss of generality. Let epsilon by definition be equal to B minus A by 2. I'm just choosing an epsilon, B minus A by 2. Let small n be greater than n epsilon. Now you should have figured out why I chose n from r plus to n. There is no guarantee that B minus A by 2 will be less than 1. That's not guaranteed. Okay. Let n be greater than n epsilon. Then we must have modulus of A minus B is less than or equal to mod xn minus A plus xn minus B. Right? But mod xn minus A is less than epsilon, but mod xn minus A is less than epsilon. Why is that the case? Simply because we choose small n greater than n of epsilon. Okay. But and mod A minus B is by definition just 2 epsilon. It's just 2 epsilon by the very definition, as B minus A is just 2 epsilon. Okay. What this tells us is that 2 epsilon is less than or equal to epsilon plus mod xn minus B. Right? That means mod xn minus B is greater than or equal to epsilon. And this is true for all n greater than n of epsilon. Okay. If you think about this, what this is really saying is that for our choice of epsilon, mod xn minus B is greater than or equal to epsilon whenever n is greater than n of epsilon. Okay. This means it is impossible to satisfy satisfy the definition of convergence for xn converging to B. For this choice of epsilon, I can never find an n of epsilon such that if n is greater than n of epsilon, mod xn minus b is less than epsilon. That's simply not possible, because after a particular stage, more precisely our choice n of epsilon, the sequence is always at least epsilon distance away from the point B. So the definition can never be satisfied for xn converging to B. So this shows the proposition and limits and limit of a sequence is unique. This is a course on real analysis, and you have just watched a module on uniqueness of limits.